Hi guys, it's me, Mrs. Garcia, and I'm making a quick video to help you guys with the assignment of figuring out if certain solutions work. So the first problem is
Mom, you mean
x over 5 plus 6 is less than 2. Yes, babe. Yes, sorry guys, that's my son. And we're gonna see if 14, 10, -21, and -12 work. So what you're going to do is there's a few ways you can do this actually. So the first way is you can solve. And so what I'm going to do is I'm going to put my line down the middle, and I'm first going to get rid of this plus 6. How do I get rid of a plus 6? I subtract 6 from both sides.
You mean erase it?
This cancels. I'm left with x over 5 is less than, if I have $2 and I spend 6, then, or I need to spend 6, that means that I'm short $4, so -4. Okay, then this is a division. How do you undo division? You multiply. So I'm going to multiply both sides by 5. The 5s will cancel. X is less than 4 times 5 is 20. -4 times a positive 5 means this should be a -20. So here's my inequality that I'm working with. Now what I do is I can test each of these in there. So I would plug in 14. Is 14 less than -20? No. How do I know? Easy peasy. A positive will never be smaller than a negative, okay? So this does not work. Then I plug in my next value. 10 is less than -20. Again, the fact that this is a positive number, positives are never smaller. The next one is a -21 is less than -20. Well, if I think about my number line, when you guys think about the positive side, you think, oh, 21 is bigger, so no. But remember, on the negative line, the further you are from 0, the smaller the number. So yes, -21 is less than the -20. And finally, -12 is less than -20. Again, thinking about that negative number line, the -12 is actually closer to 0 than it is to the -20, or -20 is farther from 0. So this is not a true statement. So of the 4 possible solutions, this is the only solution that works, okay? So that's one way of working out these problems. Another way of working out these problems would be actually plugging each one in. So I'm going to do that with a second example. I have 7 is greater than or equal to 3x plus 4. And the values I want to test are 4, 1, 2, and -1. And so what we're going to do is we're going to plug these values in for that x. So the first one says 7 greater than or equal to 3 times 4 plus 4. 3 times 4 is 12. Bring everything else down. 12 plus 4 is 16. So is 7 greater than or equal to 16? It is not. So that solution did not work. Then we would plug in another one. Oh, sorry about that, guys. 7 is greater than or equal to 3 times, we're going to try the 1, plus 4. 7 is greater than or equal to 3 times 1 is 3, plus 4. 7 is greater than or equal to. 3 plus 4 is 7. Woohoo! It works because it says or equal to. So this works. We're going to try and plug in the next one now. 7 is greater than or equal to 3 times 2 plus 4. So now we have 7 is greater than or equal to 3 times 2 is 6 plus 4. 7 is greater than or equal to 10. 7 is not greater than or equal to 10, so this solution does not work. Then we test our last value, which is negative 1. 7 is greater than or equal to 3 times negative 1 plus 4. 7 is greater than or equal to 3 times negative 1 is 3. A positive times a negative is a negative plus 4. Okay? 7 is greater than or equal to, well, if I have a negative $3 and somebody, or a better way is you subtract those, 4 minus 3 is 1. And what did I have more of? I had more positives than I did negatives. So our answer is 1. So is 7 greater than or equal to 1? Yes, it is. So the two solutions that worked here were 1 and negative 1. So that's two different ways that you can solve. The choice is really yours. I think in the long run, if you do the first way that we did in this example, it's a little bit easier to just like mentally plug this in than it is having to test each one out. However, that's your preference. Okay, so what I'm going to do is I'm going to work out one more. And this one is 7x plus 1 is less than or equal to 15. And my preference is just to solve to where we get the variable isolated and then plug in. And we're going to be testing 5, 2, 1, and negative 2. So I'm going to put that line down the middle. I first want to get rid of my constant, which is a positive 1 or a plus 1. And we do that by its inverse of negative 1 or minus 1. These cancel. 7x is less than or equal to 15 minus 1 is 14. Then I'm left with the multiplication of 7x. To undo multiplication, we're going to divide both sides by 7. These 7's cancel. I'm left with x is less than or equal to 2. So now I can do mental math. I plug in my 5. Is 5 less than or equal to 2? No, it is not. Then I plug in my 2. Is 2 less than or equal to 2? Yes, because they are equal. There's one solution that works. Then I plug in my 1. Is 1 less than or equal to 2? Yes, it is less than 2. So that works. And then finally, I plug in my negative 2. Is negative 2 less than or equal to 2? Yes, negative 2 is less than positive 2. I'm so sorry, my daughter's screaming in the background. So for this example, I had 3 numbers that actually worked as a solution. I hope that this video helps you in working out your assignment on this page.